Now let's understand what are decorators. So decorators are basically special annotations. They basically enhance the behavior of properties and methods. So they basically add certain extra behavior, certain extra capabilities to methods and uh, properties. And they are prefixed with @. And these are the three decorators which we use in LWC. Okay, so let's understand those. So the first decorator we are going to understand today is @API. So basically, the use of @API is to expose a property or method, right? It basically makes a property or method public so that the parent component can access them, right? So makes properties and methods public. Parents can pass data into public properties. Similarly, parent can also call public methods of child component. Okay, so when they are in hierarchy, so the parent will be able to access the child components properties and child components methods if they are marked as @API. And whenever the value of the property which is marked as @API changes, the child component re-renders. Okay, so this happens automatically. And then this is also used for component communication. When we want to communicate from parent to child, we used @API property, basically the public methods and public properties. Okay, so any questions so far on @API? So let's say, for example, we have two components, right? So there is a child component and there is a parent component. So parent component is inside child, like child component is inside parent component, and child component has, let's say, @API property, a message, and then @API method. So these are public, right? These two are public, but these two are not public. So these are private. This is a private property and this is a private method. So the parent component will not be able to access these, but it can call these two. Okay. So that's what basically @API makes a property or a method public. So is that clear to everybody? Cool. So let's just see a quick demo of it. Yeah, let me know when you can see VS Code. You can see VS Code, right?
Yep.
Okay. So I have basically created one component called parent demo. And what I have also done is I have marked it as expose true. What it basically means is it can be used inside our application. If we make it false, then we cannot use it anywhere. Maybe it's still under for development, so we don't want to use it, then we will make it false. But if we want to use it, we have to make it true. And we have to also give targets, right? Where we want to use this component. So I'm currently saying I'll use it in app page and record page. Okay. And then if you look at HTML, there is nothing. So basically I have added one card component and then just one paragraph, which says parent component. And JS is currently empty. Okay. And when I load this, I have added it into one Lightning app. And when I load this, it just says parent component, right? Nothing fancy, nothing big here, right? It's just displaying whatever we have added in this HTML. Okay. So now let's add certain things. So I want to basically make one counter. So every time I click a button, the counter should increment. So for that, what I'll do, I'll first create a property. Let's call it as count. Okay. And I'm initializing it to 0. Okay. And then I want to use this property here and I want to basically display count. Let's say div or maybe p. Yeah, let's make it p. And then inside this, I'm going to display count. So If you want to display anything or you want to use any of the properties of the JavaScript file from the JavaScript file, you will have to use these curly braces. Okay. And now let me deploy it. And it's basically displaying its value, right? 0. So now let's make it work, right? So I want to add a button. So let's add a button. I'll use lightning button. Label, let's say increment. And on click of this button, I want to increment this count. Okay. So I'm going to add an on click action. And I want to call, let's say handle click method. So far I have not written it. I'm just creating it just now. So I'm saying whenever this button is clicked, call this handle click. So I'll have to create that method here. So I'll create a method handle click, and this method will take an event. So whenever that click is happening, it will pass an event. And from this event, I don't need this right now. I'll show this later. Right now, I don't need it. I just need to increment this count. So whenever I want to update this count, I should say this dot count and plus plus. Okay, simple. So let's deploy this and reload. And I have an increment button. So whenever I click, the value is incrementing, right? Simple. There is nothing complex here. So there is a button. Button is calling this handle click, and handle click is incrementing the count. And whenever this count value is changing, it is reflecting in the UI. Okay. So one thing I want to do here is this 9 is looking very small. I want to make it look a little better. So you can see like some of the components are already having the CSS, right? So for example, this increment button looks like lightning button, right? Because I am using here lightning button. Suppose I don't use this, right? I can use just a button. And let's say this is just a simple button. And this button does not have anything. Let's say I'll say increment. Let me deploy this. So what we are seeing here, this button will still work, but that is not looking like a lightning element, right? So that is because we are using a normal button. So what happens when we use lightning component is we are using it from Salesforce Lightning Design System. So Lightning Design System already gives us all the CSS. So we just have to use it. Otherwise, we will have to write our own code to make it look good, make it look like a lightning button, right? So we'll cover about Lightning design system in one of the upcoming classes. So for now, let's I wanted to cover, make sure that you know that these components are coming from Lightning design system. Okay, so let me go back. So let me make this a lightning button and save it. And now I want to make this count look a little better, right? So what I can do, I can actually create my own custom CSS if I want to. So in this parent demo, right now there are 3 files, HTML, JavaScript, and there is a configuration file, which is a metadata file. So I can just add a new file here, new file, and I'll have to name it same way, parent demo.css. And inside this, I can write my CSS. So I want to create a class, say let's say counter. And for counter, I want to say color is blue and font size, say extra large. Okay. So I have created one CSS class. I'm going to apply this. So I'll apply this to this class. Okay. So let me deploy it. Okay. See, this is looking blue now, right? And it's looking bigger. So basically what this demonstrates is we can use styles from Lightning design system and also create our own styles if we want, right? So there is no restriction. But by default, it uses styles from Lightning Design System. Okay, so now this simple counter is working. So what I want to do now is I want to create one more component, and I want to include this count, display this count in that child component also, right? Whenever I click this button, it has to increment in the parent component and it has to increment in the child component. Okay, so let's create one component. So I have created one child component here, and it is actually right now having nothing. So let me remove this also. So this is a blank component right now, and JS is also, there is nothing. So what I want to do, I'll create one count here, and let's initialize it to 0. And I just want to display it in HTML, right? And let me add some styles. So basically to add this, I'm using a lightning card, and let's say this. I'm just copying it. Lightning card. And let's call it child component. And I'm just going to display count. Okay. So if you have any questions, stop me. Okay. I'm just going on explaining. So just stop me. Okay. And also what I have done, I have created one CSS here, and here the counter will show in red color. Okay. If there is like, if I put that class. So let me put this in a p tag and make this to use class counter. Let me deploy this. So now I have created the child component. I want to add it in parent. Okay, I want to add it here, let's say. So if I want to add it, I'll have to say C hyphen. So if we are referring to any custom component, we have to first say C hyphen and then the component name. So child, and then you'll have to hyphen say demo. So component name is like this. Component name is child demo. If you want to refer it in HTML, you will have to like write like this. Wherever there is a capital, you have to include one hyphen and then demo. Everything is small. Okay. I'm just adding this. And then I know that this child component has one property count. So let me pass that. Okay. So if I want to pass it, I can say count is equal to what it should have, the count from the parent component. So parent also has a count, right? So parent has a count property. I'm going to pass that. So there is a count property in child and there is a count property in parent. So to the child's count property, I'm passing the count from parent. Okay. So let's deploy this. Let's run it. Okay, so there is a count displayed here and there is a count displayed here in parent and child. So whenever I click on this button, it should increment in the both places, right? So let me do this. So I'm clicking on the increment button. It's only changing in the parent. It's not changing in the child. So there is something wrong, right? Something we are missing. So basically what we are missing is in the child component, this count property is actually private, right? So even though we are passing this value here to this count, we are passing some value. Because this is private, parent cannot access it. It is not throwing an error, but it cannot access it, right? So if I want to make it accessible, what should I do?
At the rate API?
Yes, just add at the rate API. Yeah. And you need to import it also. You need to import it from LWC. So let's deploy this. Okay, let's go back. So now let's see. See, it is incrementing at both places. So basically what is happening? When I click on this, the parent's count is incremented and then that count value is passed to the child, right? And because we have made that public, the parent can access it, right? Is it making sense to everybody? the use of @API. So let me remove it one more time. So I'm removing this @API from the child. I will deploy it. So let's reload. I'm clicking on increment button. It's only incrementing in the parent because right now the child's count property is private, right? The parent cannot access it. The moment I add it @API, it makes it public. And then let's reload it. Now it's incrementing at both places. Any questions? Any doubt? Okay. So let's go back.
Vijay, one question.
Yeah.
Because of any reason, let's say the attribute on the child, the count value of the child is increased. So will the same reflect on the parent component, the parent attribute as well?
No. So it's always one way, parent to child.
Okay.
So if we want to go other way, we'll have to use events. We'll see in the next class.
All right.
Cool. So basically we understood @API, right? It basically exposes properties and methods to the parent component, and parent can update it, access it. So that's it, right? If it is private, it is private. It is contained within this child component. If it is public, then it can be accessed. Okay. Cool. So let's move on. So the next decorator is @track. So what @track does is it makes an property reactive or trackable. So what it means is when we say reactive, whenever something changes in the JS, in the JavaScript, in the backend, it has to reflect on the UI automatically. So that's what reactive or trackable means. I'll show you. So this basically ensures that changes to properties reflect on UI automatically, right? And it also says primitive properties are reactive by default. So if there is a primitive property like number, string, anything, so you don't have to use @track with them, right? So they are reactive by default. And when we are working with objects and arrays, we will have to use @track. Okay, that's important. Otherwise, the changes will not reflect. And some objects, basically simple objects, are actually reactive, right? So primitive properties, we know they are reactive by default. Simple objects are also reactive. And @API property is also by default reactive. Okay. If you want to make objects like nested objects, some complex object or arrays reactive, then you will have to use @track. So the general rule is with objects and arrays, always use @track. And with primitives, if you want to use, you can use it. There is nothing stopping you. There is nothing wrong in using @track with primitives also. One second, I'm muting. Okay. Yeah. So there is nothing wrong in using @track with primitives. You can use it or you can leave it. It's optional because those are uh, trackable by default, right? So basically what this means is if there is, this is my JS file and this is the UI. So whenever, if I say this at the context is @track, so this is a reactive. So whenever values change in this context array, it will reflect in the UI automatically, right? So changes to context reflect automatically. But suppose this opportunities array is not @trackable, which means the first time it will load. First time it will load all opportunities, but anything changes in the opportunity array, it will not reflect in the UI. So that's what @track is. Any questions? So let's do a demo for that. Cool. So let's say I want to create an array. Let's say it's a list of tasks. Okay. So tasks is my property. And by default, let's say it has a couple of tasks. Task 0, task 1. Okay. And what I want to do, I want to display these tasks in my component. So sorry, I am adding it in child. Okay, let me add it in parent. Let me add it in parent. So in parent, I am adding one property called tasks, and I want to display it here. So let's say I want to display here. So to display a list, we have to actually use something called template and for each. Okay. So for each tasks and for item task. So basically for each task in this task list, for each task, so display task, basically task name, right? So that's what I'm saying. Okay. So if I want to do this, like I want to loop through certain things, I'll have to use this template for each, right? So we'll see more such things in the upcoming classes. So today we are learning about this. We'll also see about if else, all of those things. Okay. So basically I'm going to just deploy this and let's run it. So it's displaying task 0 and task 1, right? Cool. So now what we want to do is we want to add one button. So every time we click on button, it should add a task, right? So let's do that. So let's say I want to add a button here. Clicking button. Label is, let's say, add task. And then what this will do, this will call on click, add task. So you have to be careful. Like if you have these codes, it will not work. So whenever we are referring to properties or methods, we have to use these curly braces and no codes. Okay. So I have created this add task. I'm calling this method, but there is no method here. So let's add it. So on click of the button. So basically what this is going to do, this dot add or this dot tasks dot push. And I want to say task plus current tasks dot length. Yeah. So I'm just giving it a name. Okay. So that's it. It's a simple method. So whenever we call the add task, it will go. It is going to add a task to this list. Okay. So we are expecting whenever we click on this button, it should add a task to the list and it should display. Okay. So let's do this. So I'm clicking on this button, but nothing is happening. So what could be wrong, right? So let's debug this. Okay. So I'm going to add a, something called debugger. Anybody knows what is debugger?
Basically pausing the execution over there.
Yes. So debugger will basically pause the execution. Okay. So when we inspect and run this, so let me inspect and I'm going to reload this. These breakpoints. Let me remove everything. Yeah, so it's loaded. So now let's see what happens. When I click on add task, nothing is happening. Okay, that's weird. Let me see if it is loaded. I didn't deploy it, is it?
You have turned off the debugger in the inspect mode itself.
Okay, okay. So when I clicked on add task, basically it came and stopped here, right? And now let's see what is there in this task. So there are actually 4 tasks currently, right? But it is only displaying 2 tasks on the UI. So let's continue. Now let me click again one more time. So I'm clicking one more time. And again, now this time there are 5 tasks, but only 2 are displaying, right? So what is wrong? What are we doing wrong in our code?
The track
So
is
this
missing.
yes, this is an array, right? And if I want to make it reactive, I want to include @track, right? So let's do this. Deploy it. And then reload. Okay, so now let's see what happens. So I click on add task, it stopped here. And now when I click next, see task 2 is added. Task 3 is added. So let me close this, add task. So you see how track is working, right? So let's see one more time. I'll remove this @track and save it. Deploy this. And when I click on this, I'm expecting task to be added, but it is not working, right? So no matter how many times it's storing it in the back end, but the thing is, it's not trackable. It's not reactive, right? So now just adding @track will make this reactive, and whenever value changes, it will reflect. So now it's adding task and it will reflect it. Yeah. So we learned about @track. So basically we'll have to use it with objects and arrays. If you are using some primitive properties, you don't have to worry. Those are automatically reactive. Okay.